In this video, we're going to continue our discussion of the chain rule. This is part 3 of the chain rule video series. So for this example, find an equation of the line tangent to the graph of this function e to the cosine x at x equals pi over 6. All right, so then we want to find the equation of the line tangent to the graph. So to find the equation of a line, we need the point slope form. Or you can use y equals mx plus b. I prefer this one. So that means we need a point and we need the slope. In your homework, sometimes you may already be given the point, right? There will be pi over 6 comma and then whatever the y value associated with that is. Here, I'm not giving you the y value, so we have to find it. So our point so far is x is pi over 6 and y. So how do I find y? It will be f of pi over 6. So plug in pi over 6 in here. So e to the cosine of pi over 6. What is cosine of pi over 6? Cosine of pi over 6 is the square root of 3 over 2. So this will be e to the square root of 3 over 2. So that is our point. So the point is x is pi over 6 and y is e to the square root of 3 over 2. Not a very pretty point, but that is our point. The next thing that we need is the slope. So how do I find the slope of the line tangent to a graph? The slope is given by the derivative. All right, so that means we need to find the derivative of f of x equals e to the cosine x and then evaluate it when x is pi over 6. And so I'm going to rewrite it over here. So f of x is equal to e to the cosine x. So I need the derivative of that. So notice that this is a composition of functions, right? What am I doing? I'm composing e to the u with u equals cosine x. So going back to kind of our composition, so then f of x is equal to y of u of x, right? So that's e to the u, which is e to the cosine x. So that's how we get our composition of functions. So when I take the derivative, so f prime of x, the chain rule says you take the derivative of the outside function. So my outside function is the e to the u. So the derivative e to the u is just e to the u, right, of our original, really. So it's e to the cosine x times, by chain rule, the derivative of cosine x. So this part over here is the chain rule. And what's the derivative of cosine x? The derivative of cosine x is negative sine x. So I have e to the cosine x times negative sine x. Now this is multiplication. So this is, I can rewrite it as negative sine x e to the cosine x. And so this gives us the slope. So we need, the derivative gives us this formula for finding slope at any point. So we need the slope when x is pi over 6. So that means we want m to equal f prime of pi over 6. So plug in pi over 6. So e to the cosine of pi over 6 times, oh, I'm rewriting it in the unsimplified way. Hang on. I'm going to use the simplified way, negative sine x e to the cosine x. So it'll be negative sine of pi over 6 times e to the cosine of pi over 6. And we already know e to the cosine of pi over 6 is e to the root 3 over 2. So in sine of pi over 6, so what is your sine of pi over 6? Sine of pi over 6 is 1/2, and then e to the cosine of pi over 6 is the square root of 3 over 2. So then this is our slope. So to find the equation of the tangent line, using our point slope form, right? Y minus y1 equals mx minus x1 with, now that we have our slope, m is 1/2 e to the, or negative 1/2 e to the root 3 over 2. And the point is pi over 6, x is pi over 6, and y was e to the square root of 3 over 2. So putting both of those in, I'm going to have y minus e to the root 3 over 2, right? Y minus the y value equals m negative 1/2 e to the root 3 over 2 times, that's our slope, x minus the x value, x minus pi over 6. And that for a quiz or a test, this will be perfectly acceptable. This is not an easy thing to simplify, but in the homework you may have to move at least the e to the root 3 over 2 to the other side. So add e root 3 over 2 to both sides. And we're going to distribute this in as well. So we'll combine some steps in here. So I'm going to have y is equal to, I'm going to add that at the end. So I'm going to multiply the slope in. So negative 1/2 e to the root 3 over 2x minus a minus, so plus 1/2 times pi over 6. So that's pi over 12 e to the root 3 over 2. And then I'm adding this right to both sides. So I'm going to have then plus e to the root 3 over 2. And this will be the equation of my line. Do we have any like terms? We don't, right? So notice that this has an x, so it's not like that one. And these, they both have the e to the root 3 over 2, but that's a pi over 12, and that's a 1. Technically, I guess you could get a common denominator and combine them, or you could factor out the e to the root 3 over 2. So I'll have e to the root 3 over 2x plus, if I take out that common term, I'll have e to the root 3 over 2 times pi over 12 plus 1. So that's another way you could simplify it, but it is not necessary that you simplify that far. On a quiz or a test, you could just leave it in the point slope form, especially for values that are this messy, right? Then if you want to put in y equals mx plus b, you can. And so this is your, right, mx plus b. So that will be your b and your m. So let's try another example with finding the equation of a normal line. In this next example, find an equation of the normal line to the graph of g of x equals cosecant of x squared plus pi over 4. So at x equals 0. So what is a normal line? So normal lines are essentially lines that are perpendicular to the tangent line. So what is the slope? So if the slope of the tangent line is f prime, then what is the slope of the normal line? What do you know about perpendicular slopes? So then the slope of the normal line will be the negative reciprocal of the other slope, right? So then the slope of the normal line will be, the symbol for perpendicular is this little upside down t. So perpendicular slope will be the negative, so 1 over f prime of x, right? The opposite reciprocal. Lines are perpendicular when the slopes are negative reciprocals of one another. So I will go the same way as I would find the slope of the tangent line, and then just figure out, take the reciprocal, and that will be the slope of the normal line. So let's find the slope of the tangent line, meaning find a derivative. So find g prime of x, in this case, right, is g. So here we need the chain rule because I have a composition of functions. Cosecant is the outside function, and then that means that x squared plus 4 plus pi over 4, sorry, that's the inside function. So what do you know about the derivative of cosecant? So if I have just cosecant x, what's the derivative? The derivative is cosecant cotangent negative, right? But because I have a chain rule, that's gonna change the inside here. So g prime of x is going to be the derivative of the outside with the inside left alone. So the derivative of cosecant is negative cosecant cotangent, so negative cosecant of the inside left alone. So I'm going to leave my x squared plus pi over 4 alone. So negative cosecant of x squared plus pi over 4 times cotangent of the inside left alone, x squared plus pi over 4, and then times by chain rule the derivative of the inside, right? So this is the chain rule step. So by the chain rule we get that, and so let's take the derivative. So I'm going to have then g prime of x is negative cosecant of x squared plus pi over 4. So this is where in my previous video I was saying be careful not to just say negative cosecant cotangent and either put nothing there or just put x. You have to leave the argument, the original thing inside the function, in there. So negative cosecant of x squared plus pi over 4 cotangent x squared plus pi over 4, and then times the derivative of the inside, which is in this case 2x. And we want to find the derivative when x is 0. So g prime of 0 is plugging 0 in here, so we're just going to have negative cosecant of pi over 4 times cotangent of pi over 4, and then times 2 times 0. So actually this whole thing is just going to be 0, right? Because when you find these values, the cosecant of pi over 4, cosecant, what do you know about cosecant? Cosecant is the reciprocal of sine. So sine of pi over 4 is 1 over root 2. So cosecant of pi over 4 is going to be just root 2. So you're going to have negative root 2 times the cotangent of pi over 4, which is 1. And then you're going to have 2 times 0, which is 0. But everything here is being multiplied, so you just get 0. So that means that the slope of the tangent line is m equals 0. So that means that we have the tangent line is a horizontal tangent line. So what does that mean about the normal line? So they have to be perpendicular, right? The normal line is perpendicular to the tangent line. So if the tangent line is horizontal, what can you say about the normal line then? This is going to be, therefore the normal line is a vertical line. So the normal line will be vertical. And what can you say about the slope? And so the slope will be the negative reciprocal, right? So 1 over 0, so it's really undefined. So, but we know that from vertical lines, so horizontal lines have slope 0, vertical lines have undefined slope. So the equation of each of these, my equation of the tangent line, the equation of the tangent line will be, because it's a horizontal line, is going to be y equals whatever the y value is. So where is our point? So at x equals 0, what's the y value? So when x is 0, plug it in, 0 squared plus pi over 4. So cosecant of pi over 4, which is the square root of 2. So our tangent line will be just y equals the square root of 2. And the normal line is a vertical line. So what do you know about the equations of vertical lines? So the equation of the normal line at the point 0 and root 2 is x equals 0. So that will be the equation of a line, just because you happen to have a vertical line, so undefined slope. And so looking at the graph of this, here's the graph. I graphed it between negative pi and pi. So when x is 0, so this is our function. This is f of x equals cosecant of x squared plus pi over 4. And we wanted to find the equation of the normal line when x equals 0. So notice that at x equals 0, the tangent line there is horizontal. So this is the tangent line. And so the equation of the tangent line at the point x is 0 and y is, what did we say, cosecant of pi over 4, which was root 2, is tangent lines, horizontal lines. The equations are the y value. So they will be y equals root 2. The normal line is then perpendicular to the horizontal line. So the normal line is going to be right on top of the y-axis essentially, so perpendicular there. So the equation of that will be x equals 0, which is essentially the x-axis. So the normal line at the point 0 root 2 then is the x value. So it will be x equals 0, which is really the y-axis, is the normal line. So if you had gotten a different value for the slope, right, like if the slope was 2 for the tangent line, then the normal line will have slope negative 1/2. So the main thing here is to remember that the normal line is perpendicular to the tangent line. So the slopes are negative reciprocals. So you will find the slope of your tangent line. So again, if the slope here, let me do a quick example here. If the slope was 2, then the normal line will have slope negative 1/2, right? The opposite reciprocal. If the slope was negative 3, then this will be positive 1/3, and so on. So with chain rule, now, right, we're doing the same type of problems, finding equations of tangent lines, finding equations of normal lines, but now we're using chain rule. And I wanted to do one with the cosecant of stuff so that we can see how the chain rule works, right? Make sure that the inside stays the same. And so the way that the chain rule then works with functions like this. So if I have f and f prime, so this is a very informal chain rule. My technical notation is coming here. So like when I have trig functions or things that and it's not just x, so I have cosine of say stuff, right? So then the derivative of cosine, you do the derivative of the outside, so that's the cosine. So it'll be negative sine of the stuff times the derivative of the stuff. So that's essentially what the chain rule is saying. So you take the derivative of the main function, the outside function, the stuff stays the same when you rewrite it, and then do on the outside times the derivative of the stuff. So e to the stuff then is, with exponentials, with e, you always get the exponential back. So it will be e to the stuff, and then by chain rule times the derivative of the stuff. So this is what the chain rule is doing, right? So my example, oops, I meant to do example, not e to the x. So example of something like this is like when we had, say my function, I want to find the derivative of e to the tangent x, right? Then the derivative of this will be e to the tangent x, you get the exponential back, times, by chain rule, the derivative of tangent, which is secant square x. And so notice that even with our exponential rule, when we were doing the general power rule as well, we had, if I had e to the 10x, what's the derivative of this? Now, based on the chain rule, this will be, you get the exponential back, e to the 10x times the derivative of 10x, which is 10. So this is what we had gotten before, but we're calling it the exponential rule, which is really the chain rule, but we hadn't learned chain rule yet. And so with things like secant of stuff, right? This is where I want you to be really, really careful. The derivative of secant is secant tangent, but you need to have the stuff in there. So it would be secant of stuff, tangent of the stuff, and then times the derivative of the stuff. So I hope that that helps with doing chain rule with these types of functions, and make sure that you keep, right, if the trig function is the outside function, then when you take the derivative of that outside function, like here, the derivative of cosine is negative sine, whatever's inside stays the same, right? So a quick example of, again, this secant will be, say, find the derivative of secant of, let's say, 2x plus 1, right? What will the derivative of this be? So go ahead, write it on your own, pause this video, do it, and then unpause to see the answer. So when I take the derivative, so hopefully you have now unpaused, the derivative of secant of 2x plus 1, right? I have secant is my outside function, so secant of stuff, the derivative is going to be secant tangent, but the stuff has to stay in there. So 2x plus 1, 2x plus 1. And then now I do times the derivative of the stuff. And so this part is the chain rule. Doing the derivative of the inside. And so when you rewrite it, what the derivative of this is 2. So then I can say 2 secant 2x plus 1 tangent 2x plus 1. And that will be my derivative. Okay. In the next video, I'm going to go over the general exponential derivatives. So instead of instead of e to the 10x, like 3 to the 10x, what does the derivative of that look like when the base is no longer e?